So I thought this time I'd try a little obfuscation and annotation just to try out some new techniques. So this graph is a stock graph for us, and basically it depicts what happens when a particular system talks to a particular coupling facility structure. And I've marked up the obfuscations and the key points in terms of names and so on. So top right we have the coupling facility name, which here is called ECF. That stands for external coupling facility. Top left we have the structure name, which is DB2 something underscore LOCK1, and to the right of that we see lock. Well, that's not surprising because this is a DB2 Data Sharing LOCK1 structure, and that's always going to be a lock structure. And bottom left, the name of the system obfuscated, and then the bottom middle, the date to which this set of data refers. And to the right, marking up the types of links, in this case InfiniBand links, and 8 of them. CIB is the acronym for InfiniBand. Along the x-axis we have, unusually, not time of day, but request rate. And the vertical axis is a whole bunch of different things. So we have the synchronous percent in purple, we have the CPU time per request in red, and the response time in blue. As you can see, the response time in blue is a constant 26 microseconds or so. Now that's pretty good that it stays constant throughout the operating range from 2,000 requests a second to 26,000 requests a second. And of that, and it really is a subset of it, we have a fairly constant 9 microseconds per request, which is a good number to use for capacity planning here. Now the difference between 26 and a 9 is mainly due to the time taken to signal over paths. Remember, this is an external coupling facility, so that's going to be a non-trivial time, particularly at any kind of distance at all. And finally, when I look at a graph like this, I'm interested in the behavior in terms of whether requests stay synchronous or not. Now the first thing to say here is that not all the requests to this structure at any level of traffic are synchronous from this operating system image. Now there are two reasons this can happen. Firstly, I know jolly well, because I understand DB2 data sharing to some extent, that a LOCK1 structure doesn't always have its requests issued sync by IRLM, which owns the structure. The other thing though, and this is quite likely to be the case here to some extent, is the dynamic heuristic for converting from sync to async requests has kicked in, and sometimes we're getting some requests going async that were issued sync in the first place. So this is just a very quick look at how I look at a particular type of coupling facility structure, namely a LOCK1. Of course, I do go into much more detail when looking at the internals of it, but this is just a sneak view of one graph amongst the many that we have.